Okay, how about chapter 5? Was it okay? Everybody else? We had a couple questions on chapter 5 from 5.2a and stuff. Anybody else have questions with 5.2a and the materials that are in there? So let's go through these guys and let's see if we can get them to work out. So this first one that's up here, I need to take a look and in this distribute the 2 times everything. So the first place stays the same. The 3 gets squared and becomes a 9. The x to the negative first becomes an x to the negative second. The bottom stays. Then I got to multiply. 4 times 9 gives me 36. X squared stays on the top. And this x to the negative second goes on the bottom. 7 times 5 is 35. And then y cubed stays on the bottom. Y to the second goes on top. And then I need to take those pieces and stick them together. So if I stick this stuff together, 36 and 35 are going to stay. The x's cancel out altogether. It's a square and a square, so they're gone. Y squared and y cubed, the 3 takes the 2 away and stays in the bottom. So you're left with 36 over 35y. So what you have. Does that help?
It didn't move it on, like on Tutor. It didn't move like the x and the y. It just had like y minus, even minus plus.
Plus, right? Because you'd have 2 plus a negative 2, which will cancel.
Yeah, that's how they did it.
Right. But to be consistent and have it go through and you follow the same pattern, because that's kind of a thing that you would do then. But if you follow a pattern where every negative exponent you move, then you're getting more consistent with it than to try to jump in and just subtract those. Okay? So that consistency ends up making things work a lot better, if you can, with that part. Then this bottom one. The 4 stays on the top. The a squared, 5 squared becomes 25. A to the negative second becomes a to the negative second. All over 35 b cubed a to the negative second. So now I'm going to adjust stuff. So 4 times 25 is 100. A squared stays. A to the negative second is going to go to the bottom. 35 stays. So I'm just kind of going through and looking at each individual one. So I'm picking out each piece and seeing where it goes. So b cubed stays on the bottom. A to the negative second comes up on top. Okay? So just get that adjustment made so that you move stuff from one spot to the other. Just negatives move. Positives stay where they're at. They can never go anywhere or move anywhere. So they got to stay exactly where they're at. Like this one doesn't move, and this one doesn't move. This does, and this does. Yep. So they change places. So now 135 have a 5 in common. So this becomes 20. That becomes 7. A squared and a squared is a to the 4th. Over an a squared. So I've got to take 4 and take 2 away. Leaves me an a squared. And then b cubed doesn't have anybody connected with it, so I have to leave it there. If you want, cross off the things as you do those. Like those two would cross off, leaving me an a squared. And then I just have a b cubed. So as you go through, you can start to see the stuff that is out of those and what happens to them. Does that help? You want some more? A little bit? Let's go back and see if I can find some other ones in here. How about this one? 3, 4a to the negative first, b raised to the negative second. That one's got lots of negatives in there. So if we distribute, the only thing it gets this negative 2 is this piece, not the 3. So 3 is going to be there. Then I'm going to have 4 to the negative second a to the positive second, because a negative 2 times a negative 1 is an a squared. Negative 2 times 1 on the b is going to be a negative 2. Then all I need to do is adjust and move things. So I have 3 on top. 4 will go to the bottom. And if I move it to the bottom, it becomes 4 squared. And 4 squared is 16. Then a squared stays on top. And b to the negative 2 will go to the bottom and become positive.
So when you have negative exponents like that, it goes on the bottom.
Mm-hmm. Yep. If they're negative in the top, they go to the bottom. If they're negative in the bottom, they move to the top. Okay? So they switch spots in there. Mm-hmm. So one goes to one spot and one goes to another. Okay? So you want to watch that and make sure you get them to move from one place to the next. How about this one? 3, a cubed, b to the negative second, raised to the negative second, all over 3, a to the negative second, b raised to the negative first. So what will end up happening with that one?
Now, sometimes there would be problems where the 3a3 would stay, but then you would put the negative 2.
Yes. Yep. Mm-hmm.
Is that what you do on this one?
Well, this one, I've got to give that negative 2 to everybody in here.
Okay.
Because this whole thing's inside of parentheses. This one that we had up above, this 3 wasn't inside of parentheses, so therefore that negative 2 didn't apply to it. So if it's inside of parentheses and it's raised to an exponent on the outside, it applies to every single individual piece in there. Okay? So 3 to the negative second, a to the negative sixth, b, negative 2 times the negative 2 gives it a positive 4. Then we do the bottom, 3 to the negative first. Negative 1 times 2 is a squared positive. Negative 1 times b is a negative 1b. And then before I do anything else, I'm going to adjust this and get them to where they're supposed to be. So this 3 is going to go to the bottom and become a square down there. A to the 6th is a negative 6 is going to go to the bottom. B to the 4th stays where it's at. Then I go to the bottom. Notice I went through each piece up here. I go to the bottom. This piece moves to the top. This piece stays because it's positive. B to the negative first goes on top. And so then all I need to do is combine my like items. The 3 and the 3 squared, this actually is 9, so 3 over 9 is going to cancel to a 3. B to the 4th and B to the 1st is B to the 5th, and A to the 6th and A to the 2nd is A to the 8th. Okay, make sense?
Yeah, I think that's where I got that issue was with my negatives and the positives. And
Yes.
I knew how to solve it out, but like towards the end, I would have
It wasn't coming together good? Yeah. Okay. Yep. Mm-hmm. This, nope, it makes it just a 3 on the bottom. This becomes squared because when I have this, I move it to the bottom. And if I square it, this whole piece is going to be 3 over 9 because 3 squared is 9. Then these will cancel. And you get 1/3. Okay? Or 3 is to the first power and 3 is to the second power. The bases match, so then I subtract 1 in the bottom. 2 take away 1 is 3 to the first power. Okay?
Which one is the one where it's not on top and bottom, it's just straight across?
Okay. Straight across, does it have, or is it just combining like stuff together? Okay, let me see if I can find one of those. A lot of the ones in 5.2 A were ones that didn't have the straight across ones. They were usually fractional. Oh, here's one. How about this one? Negative 4 times 3x to the negative first, y to the third, raised to the negative third. I don't know if that's what you're talking about, or are you talking more 4x to the third times 3xy squared times 5x.
Yeah, and then when like everything is small, it's not like on top and bottom like a division.
It's all straight? Okay. This is more of the 5.1 than it is 5.2. But when you do these type, you're going to go and multiply 4 times 3, which is 12. 12 times 5 is 60. So all I'm doing is I'm going through and taking my numerical pieces and multiplying them. Then I want to go through and look at my x's. So I have x to the third, x to the first, and an x. So 3 plus the 1 is x to the fifth. Then finally, no y's here, but a y squared and a y to the sixth gives me y to the eighth. Okay, is that helping? Okay, so hopefully when you get back in it, you can take a look at it and then it'll work. Okay, hopefully. Keep your fingers crossed. Maybe what you can do at the end of class is pop back into that instead of working on something else, and I can wander around and help you. Okay, yep, so that will work. Anything else of the rest of you, anything with 5.1, 5.2a or b? 5b was the scientific notation, so you need to put that into your calculator and do that part. Okay, so that's what we got with this piece. Anything with these now? Are we pretty good? Think we're pretty good? Okay. 5.3 is taking some stuff that we've did in the past and just applying some different information to it than what you have had before. So let me get this sheet out of the way and we will start a new sheet. So 5.3 is looking at polynomials. And with polynomials, we've had them. We've had them since chapter 1, actually. And we had never given them any kinds of connections or any kind of names or any kind of meaning to what they were. They were just a group of terms that we had. So one might be 3x squared plus 4x to the 7th minus 8x to the 3rd plus 9. Maybe that's what we have. Okay, and so all of these terms, again, reviewing what that is, the terms are the pieces that create it. The sign in front of the term tells me what the sign of that term is going to be. So this is a plus 4, this is a minus 8x cubed. So this is very important that I pay attention to that because that tells me my number that I can combine or put together. The other piece we have in here is x's, which are variables, of course, and the variables are raised to certain powers in there. The 9 at the tail end is our constant term because it does not have any variable with it. So it's constant. It stays as a 9. Regardless of what I do to it, it's always going to end up being a 9. So that part won't ever change. So that piece stays the same. But each of these, the variable, right at the moment, I have no clue what it is. But in this section, we can assign it a number. We can say x is equal to 7 or x is equal to -1. And we will work on those as well and see what we can end up getting accomplished with that as we go through these. So these kind of fit in there to our different categories and our different pieces that we happen to have. And so what we have in naming polynomials, you have a monomial. A monomial is a single term polynomial. So an example of monomial might be 3x, or it might be 7x to the 5th. Those are monomials. Single terms, single pieces, nothing else connected in with those, but that's what they are. Then we have one that you're going to hear about a lot is a binomial. And a binomial is a two-termed polynomial. So it's got two terms. So we might have something like 3x plus 4 or 7x minus 8x squared. Those might be considered binomials. And we're going to run across binomials quite a bit. So again, keep that term in mind of what that means. And then the last one is a trinomial. And a trinomial, what do you think? Three terms, yep. So a three-term polynomial. So it might be 3x squared plus 4x minus 7, or who knows? It could be anything that, again, has three terms. 3x to the 4th plus 7x to the 7th minus 9x. Maybe what our trinomial happens to be. So anything after three terms is just simply called a polynomial. So it's a 4 or more termed polynomial. So we're going to have more than that. So this one that I had at the very top, the 3x squared plus 4x to the 7th minus 8x to the 3rd plus 9 is considered a polynomial because it has multiple terms in it. So polynomials, if you're looking at what defines a polynomial, is a polynomial can only have whole number exponents and all the same variable, but different exponents. So it's going to have all those things in there. So we've got a whole variety of stuff that's happening with that one, and so that's what comes out of it. Okay, so far so good? So something that's not a polynomial, this is not, and you're going to have to identify these things, is x to the 4/3 plus x to the 1/2 minus 7. This is not a polynomial, okay? Not a polynomial because it has multiple things, but they are fractional values. That, if we graphed it or took a look at it, is going to come out to be some weird looking thing. Okay, so therefore this not a polynomial. So anytime you got these fractional exponents in there, we're considering it not to be a polynomial. So be careful and watch for these fractional things, and it will ask you that. Maybe we can take a look at what's going on with this assignment as we get through with this piece. So far so good? Okay. The other piece they put in here is the degree of the polynomial. And the degree is the highest exponent on a variable. So the highest exponent on a variable. So if I had 7x to the 3rd plus 4x to the 5th minus 9x to the 4th, and I look at this thing and I want to find its degree, and it'll say, what is the degree of your polynomial? So the degree of my polynomial is 5. So it's the highest exponent that I happen to have in there. So 5 is that. And then at the same time, it's going to ask you, what is the lead coefficient? So lead coefficient is the numerical value of the highest degree term. So I want to look at that and I want to say, okay, what is the highest degree? The highest degree was 5. So this lead coefficient is going to be a positive 4. Okay, that makes sense? Pretty straightforward, pretty easy stuff there. So here's another one. We had 3x to the 4th minus 7x to the 9th. And so we could ask you, what kind of polynomial is this? So what kind of polynomial is it? 2 terms, it's a binomial. What is its highest degree? And what is its lead coefficient? Yes. Yep, -7. You need to watch your sign that's ahead of it because that's a -7. So my lead coefficient is a -7, not a +7. So that's kind of an easy mistake to make because you don't pay attention always to the sign that's in front. You're just looking at the number and thinking, I just got to get this number in there and then everything's good and stuff. But sometimes you got to watch those and make sure that you're looking at your pieces. Okay, so how about this one? If I had 8x to the 2nd minus 4x to the 8th minus 3x to the 9th. So what kind is it? Try. And its highest degree? And its lead coefficient is a -3. So pretty straightforward stuff. Okay, so I think we got that, don't we? We need to do another one. Okay, well, as long as we got that stuff in place, we are pretty good to go with those kinds of things. So making sure that you look for your degrees and your highest exponent pieces with those. Then they tell you about combining like terms. So now if we combine like terms, we're back to chapter 2. And so if I had 3x squared plus 7x minus 4x to the 4th plus 3x squared minus 6x, and you looked at the whole thing and we want to combine it, what would my combining come out to be? So I'd just go down my lines here and see if I had any more x squared. So do I? Yep. So I put those together. So 3 plus 3 is 6x squared. Then I need to look, see if I got any straight x's. And I've got a straight x. So 7x minus 6x is an x, positive. And last of all, this doesn't have anybody to combine to it, but it comes along. And then they sometimes have you put stuff in descending order. And that is from the highest exponent to the lowest. So if I put this in descending order, it's going to be a -4x to the 4th plus 6x squared plus an x. Okay? So if it asks you for descending order, that's what's meant by that. We need to do descending order because as we get to the tail end of chapter 5, which is 5.7, it's going to be dividing, and we need to have all of our stuff in descending order. So we got to make sure we get them in that correct order and correct sequence with those. Because of the exponent. The exponents, okay? Highest exponents, okay? You're thinking numerical, that's fine. If you're thinking numerical, then no, it's not. But based on exponents, it is the highest exponent that I have. Nope, you're fine. You're fine, you're fine. It's a good question to ask because sometimes you look at it and you think, what is that part that's going in there? So yeah, no, we're good. All right. So we want to make sure that we do that and we get our descending order. Think you're okay with combining like terms? Again, it's just looking at them, seeing what can be put together, and that isn't anything new than what we did before. Okay? So in sticking them together, you just want to make sure that you have those things together and what you have going on with those. They also do evaluation. Thanks. So evaluating an expression. And when you evaluate an expression, what that means is that you're going to replace x with a value and solve the equation. And we also did this back in chapter 2. So kind of a good idea to review this stuff. It kind of fits in with your exam stuff too, which is down the road not too far. We only got, what, 5 more weeks or 6 more weeks, 5 more I think it is, of class, so we don't have much more to go. So anyway, when you evaluate an equation, so if I had 2x squared plus 4, and it tells you that x is equal to 3, what would be my solution? So I would go back, replace x with 3, and solve it. So 3 squared is 9. 9 times 2 is 18. And 18 plus 4 gives me 22. Okay, so I'm just replacing and pulling out what x is, sticking another value in its place, and then solving my equation. Okay, and we did this. You guys remember that? Yeah. It hasn't been, I mean, it feels like it's been a long time ago, but it hasn't been too awfully long ago. Okay, then, how about this one? 3xy plus 7x squared minus 4y. And they tell me that x is equal to 2 and y is equal to a negative 3. What is that going to work out to be? So again, replace each piece. So I'm going to have 3 times 2 times a negative 3 plus 7 times 2 squared minus 4 times a negative 3. So what are we going to end up with for an answer? Again, order of operations is really important in there. So you want to make sure that you look at that piece and work it out based on order of operations. So that means I got to do my square first. So then straight multiplication, 3 times 2 is 6. 6 times a negative 3 is a negative 18. 7 times 4 is 28. Negative 4 times a negative 3 is a plus 12. So 18 from 28 leaves me with 10. 10 and 12. I guess I must be stuck on getting 22s all the time. So we end up with 22 for this one, for my final answer. What do you think? Okay with that? Be really careful about squares when you're doing these. One new piece I did add in here is they may give you the equation of 3x plus 4. And instead of replacing x with a number, they replace x with a plus 2. So wherever I have an x in this whole equation, I'm going to stick an a plus 2. So 3 times a plus 2 plus 4. So we're pulling out a piece, we're replacing it not with a number, but with a binomial, and then I just need to distribute like I did back in chapter 2. So 3 times a is 3a, 3 times 2 is 6, plus 4. So 3a stays, 6 plus 4 becomes 10. So this would be the answer I would enter, right? So you're pulling out what you got in there and replacing it with a letter piece, okay? You do another one of those? I think we might, let's do one more, just out of curiosity. See if you guys can get the answer to this one. 4y minus 7, and we're going to replace y with 2b plus 8. See what comes out of that one. So see if you can work it out. Figure out what your answer would be. And hopefully you got 8b plus 25. Yes. You got it? Yay. Good. Good, good, good. Okay. What do you think? You handle this? Okay. So we had highest degree. We had lead coefficient. We've had replacing something other than just the letter. We've replaced it with numbers. We've replaced it with a binomial. That's what goes on in this section. Okay. So not too bad. Right? I told you the other day that 5.1 and 5.2 are probably your toughest parts in here. That's probably about what it remains, okay? The last section we're going to do today is 5.4, and 5.4 is adding and subtracting polynomials. The adding part is not bad. The subtraction part, you have to make sure you are very careful and change all of your subtraction symbols within those. So if you had 4x squared plus 3x minus 8, and we're going to add that to 7x squared minus 9x minus 4, what would my answer be? So we kind of did these before. With addition, I'm good to go as it is, because all I'm going to do is take 4x squared plus 3x minus 8 plus 7x squared minus 9x minus 4. I just drop my parentheses, and now I can go through and stick my pieces together, just like we did in last section of combining like terms. 4x squared and a 7x squared is 11x squared. Positive 3x and a negative 9x is a negative 6x. And last of all, a negative 8 and a negative 4 is a negative 12. So in addition, you just go through, change your signs, and make sure that you end up getting those things added together with what you've got and what you do with those. I think we're okay there. Just make sure they match. They have to match with squares if they're squares, singles if they're singles, so just be really careful. And constant terms go with constant terms. So just watch your signs in there. In subtraction, if you had a negative out in front of 2a squared minus 4b plus 7, if we had this, for instance, this negative out in front of here would change every sign inside. So it's taking a negative 1 and timesing it by each piece that you happen to have. So a negative 1 times a positive 2a squared is a negative 2a squared. Negative 1 times a negative 4b is a positive 4b. Negative 1 times a positive 7 is a negative 7. So we end up having that part in there. And so it's just basically changing your signs on this part. So again, distributing and making sure everything gets a negative. Now if we put it together in a subtraction problem, what's going to happen now? So this first piece, does it change? It doesn't. This piece stays exactly as it is. So it's going to just be 4x minus 8x plus 7. But this piece, because it's being subtracted, I don't want to just take it as it is and write it down here and change it. I want to take this negative 1 that's out here and multiply it by every piece that's in there to get what I'm subtracting. So a negative 1 times a positive 3 is a negative 3x squared. Negative 1 times a negative 8 is a positive 8x. Negative 1 times a positive 9 is a negative 9. So if I change all those and I go through and I get these things all going like they should, now I can go back through and look at pieces and combine them. So 4x squared and a negative 3x squared? Negative 8x and a positive 8x? Long gone. Positive 7 and a negative 9? So that becomes my answer. Okay, so it's just that sign change. It's just making sure that you go through and get what you have in there and make sure your signs get changed on what takes place with that. So how about this one? We'll do one more. Negative 7x squared plus 3x minus 13 minus negative 13x squared plus 24x plus 11. See what you get for that one for an answer. Biggest problem with these is you don't write something down right when you work with them, so be real careful with that part. Yes?
Will all of these be in, will all the answers always be in the same order?
Not always. Not always. The ones that I put up here have been because I put them that way. The question was, are they always going to be in descending order? Not necessarily. They kind of hop around and might do something different within them.
If you put them in descending order for everything, will it mark it wrong?
No, it should be fine. If you don't put them in descending order and put them in, it should be fine also. I don't think it's that picky on what it does do with those. So, yeah, you just want to make sure that you go through and do them. It's just the ones that I picked out have been in descending order, so they're not always. This one's a little bit different. Oh, were we okay with that answer? Okay. The reason this one's different is because it puts all the brackets and parentheses in that we had back in chapter 2. So when you do this one, we need to start inside our brackets first. And this is a 4. And so we can get all the multiplication and combining this part together. So 7x and the negative just comes down. So I get 2y. 4 times y is a plus 4y. 4 times a negative 3 is a negative 12. Minus 5. So all I did in there is remove my parentheses. So I just multiplied everybody inside there by 4, and away we went. Okay? So then what comes out of the inside of this? 2y and 4y is 6y. Negative 12 and a negative 5 is a negative 17. And then the last piece I need to do is change all my signs. And that's as close as I can get to an answer because x's do not combine with y's. And so that becomes what my solution is. Okay? That makes sense? Again, be careful and go through and get your stuff figured out from the inside of them. Here's one where it looks like that one. So how about this one? 4a minus 4 times a minus 4 plus 5a plus 3. Are we good with that one? Okay. This one here has an A out in front. But whenever we multiply an A times an A, what do we get? A squared. A times a negative 4 is a negative 4a. Inside of here, I have 10a. Negative a times 5 is a negative 5a. Negative a times a negative 6a is a positive 30a. So then, if I pull everything out, it's a plus out here, so nothing has to change in there. So I just drop my parentheses, or my brackets in this case, and now I can go through and put my stuff together of, whoops, this is a squared on that 30, and put my pieces together and come up with what I would have for an answer. So a squared and 30a squared is 31a squared. Negative 4a and a positive 10a is positive 6a. Minus 5a is a plus a. And that becomes my solution. Okay. Later on in chapter 6, we'll take stuff like this and we are going to factor it, but we're not quite there yet. But we'll talk more about that next class because the foiling and stuff we do is going to reverse in chapter 6. Be good, you think? Think you can handle all these? Yes?
I just got a quick question. Like, on the stepping step, you got 30a squared there. So you...
Oh, it shouldn't be 30. I'm sorry. Thank you for mentioning that. It should have just been 6. Negative 1 times a positive 6. I don't know why I had 5 in there. Yeah. No, that makes a big difference, doesn't it? Yeah, because it should be a negative a times a negative 6a is a positive 6a squared. Yes, 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 yes. And so this isn't right. So a squared and 6a squared is 7a squared. The rest of the a's are perfect, though. It's just that first one. Thank you for saying that. Somehow in my brain I had a 5 in there. You're like, what? Thanks, Paul. Yeah, if you ever catch me doing something like that, say something so that we can end up fixing it. But yeah, it should have been a 30 because -1 times a -6 is a +6, not a 30. Like, where in the world did I get that thing from? Okay, so you think we're good? Okay, then you can take the stuff and take the rest of the time and work on your homework. You'll probably get a bunch done today in here because the assignments don't really take that long to do.